It's time for Astronomy Daily Live. Hey, everybody, come on in, join the circle of friends, the ever growing circle of friends, into this virtual uh, lounge area. Sit back, relax. Let's talk astronomy for a while. As you can see, I'm still. Let's see, can I? Where's the sun back here? It's right there. So I've still got sunlight here. Still got a little bit of sunlight left, but it's going as we speak. I'm going to hold my hand up here, and you can watch the sun fade with me. It's getting really close to sunset here in southeastern Arizona. So hope everybody had a great day. It was pretty good here. So, it's the desert, so it's dry. Starting to get a little bit warm, but I like the heat. I like the heat, so no problem at all. And as we're watching the sun go down, you can look here in the background at the 8.4 meter mirror that had just been made um, a couple of maybe a month or so prior to this uh, picture being taken. And yes, indeed, I'm one of the people over here somewhere. So, but I'm just watching the sunset. It's getting fainter and fainter. We need to. There we go. There's a good spot. It's getting fainter and fainter. I'll sort of hold my hand steady so you can see it go out. You know, I I absolutely, totally enjoy the sunrise and the sunset. I think it's very cool. Of course, that's a total misnomer, right? The sun is not setting. The sun is not rising. The Earth is simply rotating. But that name has stuck, and people like Bucky Fuller, who I thoroughly admire, um, it's uh, tried sort of in vain to change some of the words that we use to make them, a little more accurate. But um, I thought, you know, I thought that I had come up with, and it probably wasn't me, but I'd heard of, or come up with some term. Oh, it's getting really faint now. Yeah, you can start seeing my whole hand. So that's the sunset light shining on my shining on my hand with the 8.4 meter one of the 8.4 meter mirrors that are now up in the large binocular telescope up on Mount Graham. I'm just south of Mount Graham, so every single day, there it goes, it's going, still there a little bit. Uh, there, there it goes. It's gone. Gone for another day. All right. Bye bye, son. See you. See you a little later, hopefully. But yeah, so I see the large binocular telescope um, structure. The dome. Pretty much every single day. It's this big huge eyesore over there in the mountains. So yeah, and that actually is the currently the largest um, uh, um, um, I guess you call it. Well, I mean, yeah, I mean, it uses two 8.4 meter mirrors. So is that a single telescope, or is that a binary telescope? You know, they call it a binocular. So, you know, it sort of depends on how you define it. But I think in terms of collecting area, collecting area, and um, uh, single mirror, it is the largest telescope in the world. There are some telescopes whose mirrors are larger, like Keck, right? Keck 1 and Keck 2, I believe, are like 10 meters in diameter, but those mirrors are segmented, right? I forget exactly how large each segment is, but that isn't like, you know, that isn't a solid mirror, and um, yeah, there are some other, you know, close ones like um, and you know, like a thing like Subaru, right, which I think is that 4 8.2 meter telescopes, but they're sort of separate, right? They're not all put together. Oh, I'm going to tweet or I forget, lest I forget, and lest I forget, I'm going to come over here and kill the live stream on my Linux machine before it kills my Linux machine. There we go. Anyway, it's a big scope. It's a big scope, and that uh, was the first mirror made for it. I forget exactly when that was. That must have been, that picture was probably taken in maybe 1997, 1998, probably 97, maybe 96, something like that. And yeah, the uh, the mirror lab at the university is absolutely amazing. Really an amazing place. I um, I actually helped uh, um, in the polishing of this mirror later on. I played a very small part, so I'm not trying to play it up in any way that I did this or anything. No. They they were they were uh, polishing it, right? Um, this this mirror lab, what it does is, see how this is sort of on this platform here. Well, this platform is the bottom. I guess you call it the bottom portion of an oven, right? It's sort of the floor of an oven, and around the edge would be walls, right? Would be walls, and then a lid goes on top, and the walls and the lid had um, heating elements on it that would, and I'm not going to go into the details here. I think I've talked about this a couple times in a couple other live streams, so you can go back and see if one of the labeled live streams has anything about Mirror Lab. Don't remember. Um, but anyway, the glass melts, right? And then they start to spin this whole thing. They spin it, right? And so what happens is that, you know, because of the centrifugal force, the edges, you know, where the glass hits the edge, it starts to pile up, right? And in the middle, it starts to drop. You know, all the glass starts to move out towards the edge, like that. And if you spin it very smoothly and at a constant speed, and I think, I'm not remembering exactly what the rate was. It was something like, I want to say it was like eight times a minute or so. Maybe it was faster than that. It spun fast enough to create a breeze, right? So I mean, it spins pretty fast. It spins pretty fast. But what you get in the end is, you know, once you keep the velocity, the rotational velocity exactly the same, what you get is a spherical surface, right? You get a sphere. And then if you now slowly, very slowly cool it down while continuing to spin it, right, then the glass will harden. And eventually, after I think they spent several months cooling this down. Um, uh, Annealing is I believe the correct term for that process. I'm just starting up the live stream here on my smartphone so I can monitor it moderately well. All right. So after a few months of cooling down, then they can take the top off, take the sides off, and call everybody in and take a picture. So this was, you know, right after it had cooled down, and they took the top and the sides off, and I can tell you it is quite awesome to stand next to this thing and put your hands on it. It's it it was like a salad bowl. I mean, it's really deep. I think in the middle, you know, if you were to make like a level line across the top, I think the middle was about like a foot and a half deep or so. So it was, I mean, it really was. It looked like a salad bowl. It was just absolutely amazing. Um, and then the long process of polishing it started, because you don't want a spherical surface. You want a paraboloid, a three-dimensional parabola. Um, and so that that's a matter of polishing, and polishing is more or less just sort of pushing the glass around, right? Glass um, glass isn't technically a solid. It's it's a liquid. It's just it's just a very well, yeah. I mean, it's sort of like a frozen liquid, but it's not a solid, right? It's just like a very cold, hard liquid, um, and so the polishing process sort of pushes the glass around, right? And if you do it in a particular way, then you get, eventually at least, the surface shape that you want. Then what you have to do then what you have to do is you have to make sure that that surface that you've created is as smooth as you can possibly get it, right? So in the case of an optical telescope, you don't want any bumps higher. I think it was, I want to say 10 nanometers, but maybe it was 100 nanometers. Don't remember. Regardless, right? Very small bumps, and so they needed a way to um, actually they had a way to test the surface, but they didn't have a any means of sort of digitally recording those tests, right? To actually, you know, be able to you know um, take a picture, look at that picture on a computer, and do the analysis on the computer, instead of somebody having to be, uh, uh, you know, I mean, uh, to do these kinds of tests, you have to be at the mirror's uh, radius of curvature. So not the focal point, but the radius of curvature, which is usually about uh, twice as far away as the focal point. So, you know, it's laying down flat on the ground, horizontal, right? And up above this, right, quite a ways up there. I want to say it was, man, it was probably, I don't know, 10 meters up or so. I mean, it was really, really, really way up there. Um, Either somebody had to sit there and make the measurements and stuff, or we could put a camera up there with a long cable and take the pictures from a computer on the ground, right? And so it just so happened that I had the kind of camera and system that was needed, and so I was sort of temporarily hired to just set up the camera and make sure the software where work to grab the images, and that's about it, right? I mean, uh, the opticians and the people that actually worked there, did the actual work. So I just made a tiny contribution to that, in that I was one of the lucky ones that was able to climb up there and look at this mirror from above, right? Which was even more amazing than seeing it, from this angle, uh, because it's like, okay, don't, whatever you do, right? Don't drop anything. Don't drop anything. Don't drool, right? Don't sneeze, right? Sneezing is probably okay, but I mean, you don't want to do that, right? So yeah, you got to be really really careful, um, when you're up that high anyway, right? But when you're right above a one of a kind mirror, something that's never, this had never, ever been done before at all. This size mirror being made ever, right? So it was one of a kind. Um, it was something like, uh, I don't remember how much this mirror costs. I want to say like 10 million, but I don't know. That sounds like a lot now. I'm not exactly sure. I should pull up my chat here. Make sure that there isn't any any stuff. Yeah, they actually melted the glass to a point where it was as viscous as water. So I think something like 1400 degrees or so, and I'm trying to remember the kind of glass that was used. What the name of it is? It's not coming to me. But you know what? When I showed this last time, I said that I only had one of these, and that is not true. So this this actually is a rejected piece of glass that went into this mirror. So they get truckloads of this stuff, about that size or so, and they run it through some kind of process to evaluate each chunk, right? Each chunk, and for some reason, this one was rejected. Now, over the years, uh, this has been dropped a few times. Um, you know, cats, one of their things that they're here to do is to put everything on the ground, right? Put everything as low as it can possibly go. So this has been dropped a couple times, um, but yeah, I said before when I showed this is that this is the last one I have, and that's not true. I've got another one. I I remember I saw it the other day, where I work. I um, um, when I started there 3 years ago almost, um, uh, I brought it in and put it on my desk, and of course, naturally, promptly forgot about it until I saw it the other day, and it's like, oh yeah, I've got another one. So yeah, I thought that I only had one left. I actually have two left, and yeah, I'm gonna keep a hold of both of these. I because I worked there, I had access to literally boxes and boxes and boxes of these things. Some pieces were really big, and some of them, you know, were relatively small like that. And I I probably grabbed. I mean, you know, I didn't want to be too greedy, but I probably grabbed about maybe a dozen of them or so, maybe up to 20 or so. And over the years, I've given them away, right? Because that's what I love to do. If I could um, give things away, um, man, I would. I would. I've said this, and I'll say it again. If this live stream ever gets into a position to like review um, any kind of gear, you know, telescopes, eyepieces, anything else, and those items are given to me, um, you bet that I'm going to give those away live. Yeah, yeah, because that is, I I just love doing that. I think that that is the best kind of economy is the gift economy, and I wish that we could all do that. I think we're slowly moving that way, but we're quite a ways away from that. But yeah, so I've only got two of these left. Here's one. You can see a big huge ding out of it there, where it must have dropped, and yeah, blam. So, but this is kind of weird. It's weird glass, you know. I mean, it's it's got a really strange color to it. I don't know if it's really showing up in this video, but it's it's got sort of this weird like sky blue tint to it. Um, and if you tap on it, right, it's sort of it's almost got a plasticky, like a hard plastic feel to it. But I mean, it even sounds. I mean, here's let's just do a little test, okay? I've got a coffee mug here, a ceramic coffee mug, and I'm going to tap it up against the mic here. So you know, protect your ears a little bit here, but I'm not going to do it um, extremely hard. Um, I just want to see if there's a difference in the sound, if you can tell if there's a difference in the sound, because I think there is. So here's a ceramic mug, you know, just a regular old thick coffee mug, okay? Okay. Okay, all right. So then I'm going to do the same thing with with this, and I'll sort of do it on an edge as well. All right. Okay. So here we go. Now I think I hear maybe some higher frequencies with this. Not exactly sure. I'm I want to listen to this portion at least of the live stream and see if I can um, tell a difference. Uh, there's Hip lurking away back on the porch. Yeehaw! Cool. Um, so anyway, you know, I didn't mean to go off on a thing there. We were merely, you know, looking at the sunset with my hand, and I noticed that you know the 8.4 meter mirror was in the background there. So it's like, oh, all right, well, I can tell another story about that. So Yeah, yeah. I was lucky enough to. I think this was the last mirror that I saw made, but um, I saw every mirror made up until um, this one. I saw the first one made, which was a 6 foot diameter mirror, which is now being used at the Vatican. Um, oh, I forget exactly what VATT stands for, but it's one of the telescopes actually also on Mount Graham, and so yeah, okay, so Hip is a ninja live streamer too, huh? Yeah, I don't know how you guys do it. It's some kind of magic. Yeah, cheers. And then I'm trying to remember if they did like a couple of 3.5 meter mirrors, and then they did a couple of 6.5 meter mirrors. One of the 6.5 meter mirrors replaced the 6 mirrors of the MMT, the multiple mirror telescope. So one of the 6.5s went there, and I think another 6.5. I don't remember where that went. And I think after the second 6.5, they made this one, the first ever 8.4, which is as big as this Mirror Lab can actually make. Now, I should just mention that this is actually this whole thing you're seeing here is sort of the top of a structure that goes down to the floor below. So you can sort of kind of see there's a dark edge here. That's actually a hole, right? Like a hole in the floor, right? And so down below on the floor below is all the um, uh, power things and all the control of computers and all of that to actually run the ovens. Um, and so yeah, this whole structure is probably I want to say maybe 15 feet high or so from on the lower floor um, up to the top of this guy or so. And as I said, I mean it's spun fast enough to create wind. So that's very cool. Cheers. And totally nerd out on making mirrors because yeah, um, quite a innovative way to make large single mirrors, and they're doing it. They're doing it. They're making the mirrors for the giant Magellan telescope right now, and I think those are also 8.4 meter mirrors. I don't know how many. Ooh, I haven't kept track of those kinds of things for a little while, so I should probably do that. Yeah, keep track. Should keep track of that stuff. Yeah, the Tom, I am just not going to jump onto that train at all. I think that's pretty interesting. Pretty interesting, but yeah, no thanks. Nice try. Um, why don't we? Why don't we do a? Why don't we do an object of the day? Yeah, let's do an object of the day. You know, just as an aside, right? Just as an aside, I I think that we've now done like 5 constellations of the day, something like that, 5 or 6. Don't remember exactly. Why is it, do you think, that every constellation except one has been in the southern hemisphere. That's a huge. I mean, we have you've seen me randomly choose which constellation we were going to sort of investigate, right? And I think you can confirm this. I think every single one except one, and that was the constellation of Hydra, um, what it was is located in the southern hemisphere. I mean, and not like just south of the celestial equator. I'm talking about South Pole, right? So, I mean, it doesn't really matter, but it's just it's like really, really. So, yeah, I mean, it doesn't particularly matter. I just think it's interesting. It's kind of interesting that most of them have been located in the South. You know, statistically speaking, and I don't know how true this is, but I mean, you would expect half of them to be in the North and half of them to be in the South. But it's like flipping a coin, 6 times and having it come up heads 5 times. So it's just a little strange. I'm sure that'll change, but yeah, yeah. I uh, I those kinds of things just pull sort of the nerd out of me, and it's like, gotta wonder about that a little bit. Yeah. All right. Well, let's do an object of the day. Let's do an NGC object of the day. So the NGC objects are 7,840, mostly non-stellar objects. So that could be galaxies, globular clusters, open clusters, um, planetary nebulae, and gaseous nebulae. Now, some of the NGC objects are actually misidentified stars. So, when they were making the catalog, they they you know uh, were trying to identify things that weren't stars, and it turns out that some of them actually are. Right. So there's a few errors there, I guess you can say. But for the most part, sorry, they they did a pretty good job. There's 7,840 of them. So let's share my screen, and we will check out one of the NGC objects. So I'm going to go to random.org. Random.org. And let's have random.org choose for us an integer between 1 and 7,840. And then whatever it is, we will go to that object and see what it's all about. So here we go. Drum roll, please. NGC 6691. Huh. That sounds intriguing. Is that a prime number? I don't know. Is 6691 prime? Let's find out. I love prime numbers. So this says, I think this says There are only two divisors, and they are 1 and 6691. Therefore, 6691 is a prime number. Cool. Cool. All right, so let's go over to Sinbad. And let's, he's scared to start Stellarium. Yeah. Well, cross at your own risk, Uncle Bill. That's all I can say. Cross at your own risk. So let's go NGC 6691. You know you're always welcome here. Yeah, as I suspected, it is a galaxy. Oh, it's a pretty galaxy though. So it's it's kind of in an interesting place. Huh. That's a little unusual. This this galaxy is um, relatively close to the galactic plane, to the Milky Way, the disk of the Milky Way. Kind of interesting. Let's see. So its celestial coordinates are 18 hours, 39 minutes, 12 seconds. Sorry about that. Making you dizzy. And a declination of positive 55 degrees, 38 minutes, 30 seconds. So it's a high declination, but you can see the galactic coordinates, which is as if, well, 0 degrees longitude and 0 degrees latitude would be the exact center of the galaxy. So then as you move one way or another in longitude, you would change this number, and this number goes from 0 to 360. And then as you move perpendicular to that line, you would move in galactic latitude, and that goes from 0 up to positive 90, which is the north galactic pole, and then 0 to negative 90 degrees, which is the south galactic pole. So as you can see, this is just 23 degrees off of the galactic disk. So yeah, we're looking through a lot of muck to see this galaxy, for sure. It says it's an SB galaxy, so S means spiral, and at least the first B is talking about how tightly wound the spiral arms are. And wait, I need to make a correction. The first B is saying that this is a barred spiral. You see this? It's sort of like they call that a bar, right? It's just this straight object. Now we're looking at this galaxy pretty much face on, sort of, either down on it or up to it, right? Depending on how you want to look at it. But yeah, there is definitely a bar here, right? And then the second B, the small b, um, gives some kind of indication as to how tightly wound these spiral arms are. And so B is sort of, between an A and a C, right? An A is a little bit more open armed. Sorry, the other way around. An A is a little more tight, and a C is a little more opened armed. There's also, like S zeros, which are really close to being elliptical galaxies. They just find a little bit of gas and dust or something, not a lot of arms. But as you can see, this has some nice spiral arms, and I can probably say too that this is pretty close to actual color. See how we're seeing a lot of bluish stars out here and a lot of orangish reddish stars in the middle. That's pretty typical. Now, because this is in the northern hemisphere, I'm wondering if the Sloan Digital Sky Survey has a picture of this too. Let's find out. Nope, it doesn't look like it does. 2MASS does, the Digital Sky Survey does, but SDSS does not. All right, well, we're sort of stuck with this one. Too bad. It's only too awesome. It's not totally awesome. Maybe we'll go over to the HST archive uh, and see if there are some HST images of this galaxy or portions thereof. We'll come back to the picture here in a little bit. So let's move down. So it's got a few other names, right? A few other names, pretty typical catalogs, ones that we are beginning to recognize a little bit. We should actually, I should devote a live stream to all these different catalogs, because see, I mean, each one of these you can click on, and it'll probably tell you a little bit about each one. Yeah, so here's LIDA, right? The Lion Mudon Extragalactic Database. So, very cool. Yeah, we should probably do that at some point. Let's just go through those, because I've never looked at those either. I don't have a clue what a lot of those are. So not a very well studied galaxy. Only 27 references. Excuse me. And it doesn't look like there's any distance measurements. So wow, we don't even know how far away it is. How big is it? It's like 1.6 arc minutes by 1.1 arc minutes. That's pretty big. So, rough guess. It's probably relatively close. You can also get sort of an idea of its nearness or farness away by its radial velocity. That is, how far away or how fast we and it are either moving away from each other or towards each other. And that's actually a pretty good clip. So the fact that it's pretty faint, pretty small, and moving away pretty darn fast means it's pretty far. It's I guess just as a moderately wild, educated guess. Yeah, it's definitely not in the neighborhood, right? The neighborhood is 200 or 300 million light years. Yeah, this might be a little further than that. Not quite sure. The fact that we're seeing structures and things on here, yeah, maybe it is relatively close. I don't know. What do I know? See if the velocity measurements all match. Yeah, they match pretty well. 5881 to 5886. Yeah. This last number is a measure of redshift, which that can be the subject of another live stream. See, I mean, there is so much to talk about in terms of astronomy. I will never ever run out of subject matter topics. I could do this, uh, you know, uh, several times a day, every single day, and never run out of topics, because it's just, I mean, there's just so much. There's so much. That's one of the reasons why I like it. Uh, is because there's just so much to it. So let's look at some pictures, and then yeah, let's go over to the HST archive too and see if there's any images or spectra or anything like that over there. But that's a pretty little galaxy, pretty nice. Looks like there's another one down here. It's smaller and fainter, so it's probably in the background. Probably. It's my, again, wild guessing here. Here's another funny looking galaxy up here. Maybe there's a star in front of it. I don't know. Let's zoom in on that. And oh yeah, no, it's just I guess it's hard to tell if that's a foreground star or if that's just a really bright center of some kind of object. That's kind of weird looking. You know, maybe it's a like a planetary nebula or something. Don't know. It's doesn't look like a typical galaxy, right? It's just got this weird bow shape to it. So yeah, who knows? Who knows? It's one of the great things is that there are mysteries everywhere. So here's some more galaxies here. Pretty amazing. There's always galaxies. Wherever we look, there are galaxies, lots and lots of galaxies. Okay, so right next to a very bright star. Huh. Maybe I should look that star up. 1842 plus 55. Wow, that's got to be in like Cygnus or something, huh? Cygnus? Let's see. I'm pulling out my Will Tyrion Sky Atlas 2000 desk edition, and I am going to see if I can find. I was really close there. Chart number 8. Chart number 8 at 18 hours and plus 55. 18 hours and plus 55. 18 hours 42 minutes. 1842 and plus 55. Kind of hard to tell. Maybe it's 46 Draconis. 46 Draconis. Let's I'm going to pull out my other charts. I'll show you these charts in a minute here. I've got the Northern Hemisphere Volume 1 of Uranometria 2000, and I'm going to look up the same coordinates here, plus 55. Plus 55. Oh, I gotta go one more. Here we go. So 1842. And closer. 1842. 1842 and plus 55. Here we go. $18.42 and plus 55. Yeah, it's actually, that is 46 Draconis, right? It's got that bright star. Yeah, and then these two stars right next to it. And then this group of three or four here. I'm seeing 3 on Uranometria's charts. And then, yep, we got this bright star and this bright star and the galaxy itself, 6691 right there. So yeah, very cool. Wow, I should take a picture of that. I should take a snapshot of that. Well, yeah, I've got it. I'm recording this, so yay. So yeah, very cool. Very cool. Pretty easy target if you're into observing, right? and you star hop, that's pretty easy, right? I mean, it's just off of this star. I guess the way I would do it, I always when I star hop, I see triangles, right? I see triangles everywhere. So what I'm seeing here is not quite an not quite an equilateral triangle, right? But here's a triangle with a galaxy at one end, right? Or at one vertex, right? The other way, I guess I'm sort of seeing a right triangle here too, right? So this and then 90 degrees over is that, and then over here. So yeah, lots of ways to star hop to this galaxy. And I guess the fact that it's showing up on Uranometria does mean that it's at least bright enough to see, with a 14-inch scope, a 16-inch scope. I don't think an 8-inch scope, the one I have, at least eyeballing it, I'd be able to see it. Photographically, of course, but eyeballing it, no, not really. All right, so that star there is 46 Draconis. Very cool. Very, very cool. It's a pretty little galaxy. All right, so let's go over to the HST, some pictures over there. Uh-oh, what is it, Sun? Yeah. So let's just type in 6691. Let's see if anybody's bothered to look at it with HST. Nope. Nobody's looked at it with HST. That's too bad. Too bad. Nobody's looked at it with HST yet. All right. Well, let's go to the references and see if there's anything necessarily otherwise interesting about this galaxy here, this barred spiral galaxy. Radiosynthesis imaging of spiral galaxies, integrated radio continuum spectra of galaxies, the 2-mass catalog, fundamental plane of spiral structure in disk galaxies. Okay. Abundance properties, disk mass survey on the relationship between disk stability and star formation. So there's this thing called the disk mass survey. Never heard of disk mass survey before. Two-mass redshift survey, the 2M++ galaxy redshift catalog. Ooh, here we go. The disk mass survey overview. Now, it's kind of interesting that an overview paper would reference a galaxy, but yeah, let's go find out. I don't know what the disk mass survey even is. And I would think that, look, at a paper entitled Overview, come on. What's the problem here, boys? What's happening here? Well, there's other ways to do this. Let's go over to archive.org and see if we can get it that way. I just have to search for disk mass in the title. Now what? Something's weird with my browser for sure. I think I can shut the browser down and Google Hangouts will still keep keep going. Is that true? Ooh, I'm going to try it. I'm going to try it. Ere I try it, I'm going to try it. Okay, I'm going to exit Chrome.